So, nuclear reactions involve the nucleus. So that is the center of the atom with the protons and the neutrons. So this is stuff that goes back from chemistry. Again, the most of chemistry that you did was about full outer shells with electrons. Nuclear reactions release so much energy because it's changes in the nucleus, which is involving the protons and the neutrons. A neutron is neutral, so it has zero, what we'd call charge, but a mass of 1. So that's where you would see up here, like the particle, a neutron. Okay, that 1, that top number is the mass number, and that bottom number is we kind of say it's the charge, but it's not the charge that we associate with electrons, but it's kind of like the charge, it's the number of like pluses, the number of protons essentially in there. And this is also the, you can look this information up on the periodic table, and this is the atomic number, which is the number of, so I'm going to actually cross out charge because that's confusing to people thinking of electrons. Just think of it as the number of protons or the number of like plus ones, and that is the atomic number on the periodic table. So if I look at this first fission reaction, fission, F-I-S-S-I-O-N, is splitting the nucleus. This is what happens in nuclear power plants. And I take a small neutron, so right here, just knowing that this is a neutron, I take that neutron and they shoot it at this large uranium-235 nucleus. So to balance this nuclear reaction, I look at all the top numbers. So the top number here, I have 1 plus 235 is 236, okay? That's going to equal all the top numbers here. So I have 90 plus 144 plus 2, because that's a big 2 in front, times 1 is 2. And if you add up all those numbers, you're going to get 236. So the numbers on the top have to sum up, and the numbers on the bottom have to sum up. So the numbers on the bottom here, I have 0 and I have 92. So it's going to be 92, okay, equals, the arrow is like an equal sign, blank, or I'll call it X, I'm thinking of algebra, plus 55 plus 2 times 0 is 0. So 92 minus 55 is going to give me an answer of 37. So I'm going to say here, if I solve that, X is 37. So I would write this number 37 down there. So that's how you're going to balance these fission reactions. I don't know if this is a super critical skill on the AP test, so that's why we're doing this very briefly. But the big idea is the mass number on the top is conserved. The atomic number, the number of protons on the bottom, is conserved. Tiny, tiny little pieces of the mass of the nucleus are converted to energy, and nuclear reactions release so much energy because you're tapping into what's called that strong force in the nucleus. So the next one below here, I will just be consistent and use red for the top line. So I'm going to have 1 plus 235, which is 236, equals 95 plus blank plus 3 times 1, so plus 3. So I get that 98, and I take 236 minus 98, and I'm going to get 138. So on here, my top number, so X is going to be 138. So my top number here is going to be, it's going to be hard to write it there, 138, okay? Now my bottom number, to figure out what that bottom number, I'm going to have 0 plus 92, so 92 equals 36 plus X. 3 times 0 is 0, so I'm just going to ignore that because it's 0. 92 minus 36 is going to give me 56. So my bottom number is 56, my top number is 138. I look at the periodic table and whatever has an atomic number of 56. And so you look on your periodic table, again, they would give that to you, and that is barium, Ba. And I got that from, this is the atomic number. So this is what you are going to write in this tiny little box here, which it's so small you can't really see it. But that's what you would write in there. That top number is the mass number, the bottom number is the atomic number. So pause the video, try the last one on your own for a second, and then I will walk you through it. Okay, so 1 plus 235 is 236 equals 87 plus x plus 3. So I'm going to have 236 minus 90, and I'm going to end with 146 is going to be my top number. On the bottom, I'm going to have 92. Oops, what did I just do? Sorry about that. All right. 92 equals 35 plus x, and it's 0 because 3 times 0 is 0. And so when I subtract that out, I'm going to get 57 on the bottom. When I'm like 57, that's the atomic number. So what has an atomic number of 57 is lanthanum, which is the La is the symbol. So this is what you're going to put in that box there. Big idea from it is we're splitting the nucleus. So in other words, what happens in a nuclear fission reaction? So big idea from this is you split the nucleus and it releases, when I say a lot, I mean a lot of energy. And where does this happen? This happens in nucleus because they're nuclear reactions, but also it happens in nuclear power plants and in old atomic bombs. But this is what happens in nuclear power plants, is nuclear fission. I hope this was helpful.